Today we are going to talk about training neural networks in Tensorflow. This is episode 3 of the series Tensorflow from scratch. Make sure you have watched the previous video before coming to this one. So previously we discussed about, we took an example and discussed it was a 2-layer rectifier linear unit network on random data with Euclidean additive loss, and then we discussed about computation graph, why is it necessary, and then we discussed about running the session, which means after we have implemented and wrote the code, written the code for computation graph, we are actually going to run it. So previously our code looked like this, and TensorFlow workflow is divided into two parts. First one is computation graph and the other one is actually running the computation graph. So the first part is doing nothing, it's not allocating any sort of memory and it's not computing any sort of gradients, and we are declaring any variables. In the session we use tf.session. In this part we are actually running the computation graph, and this is where all the computation and allocation is happening. So in this video we are going to talk about the bottommost part, which is about this for loop. So this runs through one backward and forward pass. So the gradient of weights and gradients of W2 just above the tf.session, this line, we are actually passing the forward pass, and then the TensorFlow is going to compute the backward gradient. It's going to do backward propagation for ourselves, and it's going to compute the gradients. And this runs through one backward and one forward pass, and it takes only a couple of lines in order to train a neural network. Now we are going to run the graph many times in the loop. So we are doing a for loop, and on each iteration in the loop we are actually calling in session.run, asking it to compute the loss of the gradients, and then we are doing a manual gradient descent step using those computed gradients to update our gradient current values of our updates. So TensorFlow gives us a bunch of options on which optimizers to use. We can use any optimizer which works perfectly or does a better job for the model, be it ReLU be it RMS prop or IDEM for that matter. So if you actually run this code and plot the losses, then you see the loss goes down and the network is training, and this is pretty working well. So let me show you the graph. So after every iteration, as you can see, we are using gradient descent, and we are seeing that the loss function is gradually decreasing after every iteration, and this is an indication that our neural network is learning. So if you actually run this code and plot the losses, you see losses go down. But there's a problem here. If you remember, in the forward pass, every time we execute this graph, we are actually feeding in the weights. We have the weights as numpy arrays, and we are explicitly feeding them into the graph. And then when the graph finishes executing, it's gonna give us the gradients, and remember, gradients are the same size as weights. So this means every time we are running the graph, we are actually copying in the weights from numpy arrays into TensorFlow and getting the gradients, and then copying the gradients from TensorFlow back to numpy arrays. And if you are running this on CPU, this is not a huge deal, but if you are actually running on GPU, we discussed that it's actually difficult to copy data between GPU memory and CPU memory. So if your network is large and your weights and gradients are too big, then doing something would be computationally expensive, and it will be a time-consuming task. And we are copying all sorts of data back and forth between GPU and CPU at every step. So what's the solution over here? So obviously TensorFlow gives us a session, and then in the next episode we are going to discuss about TensorFlow variables which live inside the computation graph. In the later videos we are going to cover about TensorFlow variables, nodes, and optimizers. So don't forget to subscribe. Thank you for watching this video, and if you have any questions regarding the content being covered in this video, feel free to leave it out in the comment section below. Talk to you next one.